Hello, JavaScript developers and Solidity auditors. Today, I would like to show you some techniques that you can use to optimize your backend processing when you need to acquire some information from Ethereum blockchain. So let me give you an example that we're going to use today. Let's say you have a list of addresses, and I'm just going to create one file where we're gonna need to get some information from, let's say, these 2000 addresses. Now let's say I would like to know every Ethereum balance for each address. So how can we do this? The trivial way is to create some processing where we're gonna just call get balance for each address, store it into the database. So let me show you how we're gonna do this. By the way, today I'm gonna use the very cool, awesome library called ethers.js. I think in my opinion, it does the job better than the Web3 JS implementation because it has some very powerful features. And it's also it's been very stable for the last couple months. So I really like it. And actually in the last couple months, Web3.js gave me so many headaches and issues whenever I try to upgrade it. So I think ethers.js is much better competitor in this space. Anyway, so let's get started. So we're gonna need to initiate a Node.js library. Node.js repository. We're gonna install the ethers.js library, and now we're gonna need to specify which provider we want to call. I'm gonna go to their documentation, check the connect to Ethereum, and I'm gonna just copy and paste this info provider, but I'm gonna call it just the provider. And we're gonna use the Ethereum mainnet network. So now let's define the function main, and we're gonna call it right away. And here we're gonna execute some code. So let's say we also need a file system, so we can read our files. Let's say our array of addresses equals read file sync, and our path addresses CSV, and we need to specify the encoding UTF-8. And I'm gonna convert this to JavaScript array because this is just gonna give me a string. So I'm gonna say split by the new line delimiter. So now we can see and check if we got everything right. Okay, looks good to me. So the trivial way of doing this, we would iterate over each address, and we're gonna call provider get balance, and we set our Ethereum balance. And it's gonna give me a big number, so I will probably need some external helpers. Format ether, for example, from ethers.utils. So here we're gonna say balance equals balance, and then we're just gonna console log every address and their balance. As you can see, we got our job done, but it's not efficient, it's very slow, and we are creating so many network requests, which is also painful to the Infura providers. They don't like people like us because we're just wasting their network bandwidth, which is also expensive. So how we can optimize it? How can we make it better? We can use the power of Solidity. So what are we gonna do? In a I'm gonna open up the Remix browser in my Brave browser. I'm gonna show you something very quick. So let's say we can write some smart contract saying contract balance Oracle. And here we're going to specify some function, get balance, and we can provide the address, user, public, view. We can even go external actually, returns unsigned integer balance. And we're just gonna say user.balance. Let's deploy this contract somewhere. Let me pause. So let's deploy this contract on Ethereum testnet : and see what happens. Deploy, sign. Let's wait when the transaction is gonna be mined. Should be pretty quick. Come on. Yep. Okay, now if we specify any address in here, let's say this address, and we can read the current value of this address, and we can check on Etherscan if it matches. Yep, looks like it's correct. So by using some, what if we can provide, instead of just single address, the array of addresses? Like, let's say, call data, our users, and it's gonna return us array of balances inside of the memory slot. Okay, let me remove this one. Okay, and here we're gonna define the new array with the length of users.length. It's a size of our array. And then we're going to iterate through it's less than users.length. So this is our basic for loop. And then we're gonna assign, let's call it balance. Oops. Let's call this balances array. Okay, so balances from I equals users I dot balance. And now let's deploy this contract. And see what happens. So basically we created a function, and we created a smart contract that has a function to insert an array of addresses and return an array of balances. So here we can say, what if I want to, oh, what happened? Oh, it's an all contract. Where is my deployed contract? I'm sorry. Let me deploy it one more time. It was probably deployed. Yeah, I think that it was this one. So we can take this address. Okay, never mind. So, oh, I think we didn't compile this contract. Yeah, that's why it was deploying the old. Yeah, it was deploying the old bytecode because we haven't compiled the new one. Yeah, always make sure you do the auto compile when you write your code in Remix. So let's deploy it one more time. And now we can provide an array, let's say of this address and my personal address, and make a call. 1 second. So the blockchain didn't sync enough. So we can see right now, I just got, in one single call, I got the 2 balances for these 2 addresses. So let's see how it can work on mainnet. So I already have deployed this contract. If we're going to switch to mainnet, and I think I just had a only different name. I called it export balances. And now I can do this, 1 second. So if we're gonna load the balance like this, I don't think that's the one. 1 second. So I have deployed this contract over here, and let's do the same call. Yep. So now we can read the balances from the mainnet. So now let's write this code in JavaScript. Let's optimize this. So now I'm gonna need to communicate with a smart contract. So we will need some ABI. As you can see, with ethers.js, it's very simple to have an ABI for your code. So for example, const ABI equals, it's gonna be array, and that's it. That's our ABI. Except we need to remove a few things to make it proper, and I think that should work. Okay, this is our ABI, and we need to instantiate the contract. So our contract will look like this: new ethers.contract. Similar to Web3.js, you specify the address, balance Oracle address. This is our address. I'm gonna copy and paste it, and we specify the address, our ABI, and our network provider. Okay, great. So now, instead of this call, we already have the array of addresses here. I'm not gonna iterate over. I'm going to call const balances equals await our contract and the function called export balances. And we're gonna put our addresses in there. Now we're gonna do the console log. Here we go. In just one network request, I was able to get 2,900 network balances in like very short amount of time. That's just how powerful it can be to utilize Solidity as your optimization technique. And if you wonder how we can parse it, I think we can just do balances equals balances.map, and then for each balance we're gonna return, we're gonna say format ether balance. I think here now we can see the formatted balances. That's it. And now, like, if you want to match them together, so the index of this address should correspond to the, let's say if we do this balance and index, let's say addresses with balances, and we are gonna return an object addresses from index and balance format ether. Ouch. I'm just gonna use the new line. Yeah, I think we need to return an object. So format ether balance. And now we can have the nicely formatted addresses with their balances. Let's see. So we have some issue. We were console log the wrong variable. So if we run it, that should work just fine. So here we go. Now we can do all kinds of crazy stuff. For example, querying all the ERC20 balances. How about this? Like if we deploy the function get ERC20 balances, and we're gonna use same kind of thing. I'm just gonna copy and paste it, but here we're gonna say ERC20 balances, and here we're gonna say we need the interface, ERC20 interface. One second. I'm gonna just Google it quickly. ERC20 Open Zeppelin. Go here, and we only need the balance of function. Okay, nice. So if we're gonna say interface ERC20, and we're gonna have this function. External, okay. All right. So now we need to specify our token address as our first function. Address token, and here we're gonna say ERC20 equals ERC20 token address. And now we can do, instead of this, we can do balance of all right. One second. It looks like, yeah, I forgot to specify it's a view function, so we can get rid of this error. All right, so I'm on mainnet. I'll need some ether. Let me get back to my wallet. Let's deploy this to colon testnet, just to quickly demonstrate you that you can do any kinds of things like that to optimize your Ethereum queries. So we can deploy this contract, and let's say we have some token here for let me check some address. Let's take this token address, and we want to call this function, and we want to make sure have this address, and let's see who is the token holder of this. Let's say some token holders. Let's have this address as well. Okay, let's say this address and this address. Call. have an extra space here. Yeah, here we go. Yeah, we can optimize anything like that. Please guys, please do so. Please optimize your Ethereum Infura calls or anything like that. If you scrape some data from Ethereum blockchain, I highly advise you to do it. Also, I want to quickly mention that this tutorial was sponsored by papersec.com. Papersec is the consulting agency that helps people to do the penetration testing, security assessment, and smart contract audit. Head over to their website and write their email if you need some help with your app development or security audits. Thank you very much. Have a great day.